So good morning, good afternoon, and good evening to everyone and all the different viewers from all around the world. Welcome to the Air Center Networking Friday session, where great speakers, interactive discussions, and thousands of proactive attendees coming from governments, academia, multilateral organizations, companies, entrepreneurs, and civil society from more than 100 countries all over the world come together to share information and insights. Let me quickly introduce myself as the moderator for this session. My name is Malik Lopes, and I'm from Cabo Verde, an island country in the central Atlantic Ocean made up of 10 volcanic islands, an archipelago with a combined land area of about 4,033 square kilometers, with an EEZ of over 720 square kilometers, located approximately 570 kilometers off the West African coast. I have a bachelor's degree in psychology and a master's degree in social and organizational psychology from the University Institute of Lisbon. My professional experience has come from public administration in the maritime field through port management, maritime economy, and blue economy as the Director General for Maritime Economy, and having recently taken office as the chairman of the board of the Sea Institute in Cabo Verde, responsible for marine applied research and technological development. Today we have with us Professor Carlo Fezzi, who is an associate professor at the Department of Economics at the University of Trento in Italy, and a senior lecturer at the Land, Environment, Economics and Policy Institute, University of Exeter in the United Kingdom. So his research at the intersection of environmental economics and applied statistics. He enjoys interdisciplinary research and regularly collaborates with environmental scientists, ecologists, hydrologists, with environmental scientists. His work includes developmental spatial models for valuing multiple ecosystem services, estimating the impact of climate change on land use in agriculture, and more recently, developing tools for integrated land and coastal management. Carlo today will do a presentation for us on economic valuation for spatial targeting of coastal ecosystems, cost conservation in the face of climate change. I would like to ask the viewers who have questions further on to place their questions in the Q&A section and not in the chat section, please. So that was a quick introduction for the viewers, and I will now ask Professor Carlo to do this the honor and begin his presentation, please. Carlo, please.
Hopefully you can hear me now.
There you go.
Yeah, I was gonna say thank you, Malik, for your introduction, and thank you to the Air Center for giving me this great opportunity to be here. As an environmental economist, I'm really keen on interdisciplinary research. So if anything I talk about sparks some interest, you think, oh, this kind of work can be related to what I'm doing, please do not hesitate to let me know later, or even at the question time, or later on to write me an email, and I'll be very happy to hear from you. And also, as an environmental economist, I do feel I have a certain responsibility here, because we are strange creatures. That's, you know, a regular economist somehow sees us as this strange being who like to hug trees, sort of tree huggers, but natural scientists and maybe conservationists, which I guess is the majority of the audience here, some of them may see us as some evil businessmen who just want to put a price on the environment and maybe sell it to the highest bidder. Some of them, I'm just saying, no, hopefully not the ones who are listening to this talk. And ideally, one of the purposes of my talk will be to show you that at the end, we can all be actually great research partner or policy, or help develop policy together, and we really work towards the conservation of nature together. And how am I going to do that? Well, I'm going to start talking a little bit about ecosystem services as a framework to do interdisciplinary research, and really try to stress the differences between values and prices, which are very different. And then I will talk a little bit about what we can do with the environmental valuation of non-market goods. And then I will focus on a case study, which hopefully can give us a lot of interesting examples that maybe can be applied also somewhere else. So this work on the case study is going to be on Maui and on coral reef conservation. And I did work on these issues while being a visiting scholar at the Department of Natural Resource Management of the University of Hawaii, together with Kirsten Olson, who is a professor there. And in the last few minutes, I will just say a few words on the road ahead, what I hope some more research in this field can bring. So ecosystem services. These are the contribution from the natural world that generates goods and services that provide welfare for people. So in this definition, I stress two words: welfare, well-being, and people. So economists always take an anthropocentric point of view. So we do see the natural world from the lens of mankind, of people, because ultimately, at the end, people are those who make the decision. But we look at welfare and well-being. We do not look at prices. So, I mean, prices is an aspect of that, and money is an aspect of that, and we try to quantify some of this well-being, some of this welfare in terms of monetary terms, but we do not focus on markets only. Okay, and hopefully by the end of this talk, I will manage to persuade you that some of these, that this type of lens, of this type of approach to looking at conservation issues can actually be used to protect the environment. Ecosystem services and working with ecosystem services is, in my opinion, a highly interdisciplinary undertake. And for example, we can think about an ecosystem, and there are those primary and intermediate processes like soil formation, nutrient cycle, all those things that an economist or a statistician doesn't know anything about. Therefore, we definitely need the input from natural scientists here. Actually, this type of research questions have to be guided by natural scientists, by conservationists. And while we move towards the right of this table, then there are things that I understand a little bit more. So we've got the final ecosystem services, which are the contributions of the ecosystem towards some goods that people value. It can be food, it can be just market goods like food, drinking water, timber, energy, these type of things for which we have a market, but also things that they have strong values, but they don't have a market, like recreation, for example. And we can put a value, we can try to estimate the value for these goods, and we can also disentangle the ecosystem services contribution to such value. For some of these goods, it will be easier than for others, okay? And for some of these goods and services, maybe we are not able to put a value. So we are only going to be able to focus on some of them. So economics doesn't have the arrogance to say that they can value the totality of the value provided by nature, but maybe we can try to pin down some of them. Okay, and another thing that I want to stress is the difference between values and prices. So some goods they do have a well-functioning market, and if we want to talk about what a well-functioning market is, we will have to have another extra hour. So I will just say there are just some regular market that you think about where people buy and sell goods. And for example, here I put just a picture of some grocery. And these markets may reflect, the prices in these markets may reflect, at least in part, the value and the scarcity that characterizes these goods. Some other goods have no markets. and therefore they have no prices. But this doesn't mean that they are not important. They can have huge values, but maybe there is not a market. And therefore, if we leave a decision to markets, then they're not gonna take into account the importance of these goods. Okay, so what's the role of economics here? Well, resources overall are limited, so there are always gonna be trade-offs between different ecosystem services, or in general between different goods and services. And if we leave decision to the markets, then the market, as they are structured, they won't recognize the values that some aspects of the ecosystem provide to people. And even if we take the anthropocentric point of view, then even if we do that, this is not going to help us, and this is gonna create a detrimental effect for people, from that point of view. Environmental valuation can help us to recognize the values that nature provides to people, and then can help us inform policy. And it can be a piece to a wider puzzle that then can help us policymakers make better decisions. And in terms of environmental valuation, I will focus on one good that is environmental economists have been valuing for a long time, which is recreation. And this is a typical non-market good. I wrote partially because there is a part of the recreation, like tourism, can be encompassed in a market, but some other parts of it, and can be just as big, don't have a market. Despite that, recreation can have huge values, and actually I'm going to show you how we can we can take advantage of these values to actually finance some conservation programs, for example, how this can be done. And before talking about the examples, which are going to concern the island of Maui, like I told you before, I'm going to talk a little bit about the methods I'm using. I'm going to talk about the travel cost method. It's a revealed preference method. What does it mean? We observe people behavior, and from their behavior, we try to estimate the values that people hold for specific aspects of the ecosystem, for recreation in this case. It's highly spatially explicit. I like it because, and these are important characteristics if you want to do spatial coastal planning, for example. And also it can be used to simulate a series of highly policy relevant scenarios, in my opinion. Let's see later what you think. I would love to hear your thoughts. So just giving you a bit of an overview on what's behind this method. We have a person, we can call this person Will, and Will has some income. And let's imagine that this person has some free time, and he can decide if he wants to stay at home. He's gonna maintain his income. He's just, I don't know, watching TV, whatever. Or he can go to the beach, for example. He can engage in outdoor recreation. If he does so, there are a series of costs that he faces. There's a fuel cost to get there. Maybe there is an entrance ticket. There is opportunity cost. There is the opportunity value of time to get there, actually. And all of these costs will diminish his income. Okay. Now we do not focus only on income. Okay. So now we have a choice between the two options. Okay. If we focus only on income, well, the person will stay at home. But that's not what happens, right? There is another thing that is more important than income, and is well-being. Economists like to indicate this thing with the word utility. They like this word utility. In reality, we could actually indicate it with smiley faces. It's exactly the same thing. So the person will do the thing that makes him happier. In this case, if the person is happier by going to the beach, it means that a trip to the beach has a higher value than the loss of income that occur to go to the beach. So this is the basic reasoning that we use to estimate the recreational value. Of course, then reality is a little bit more complex. We have various recreational sites. There is a beach, maybe a lake, maybe we'll like surfing. So there is another type of coastal site. And we assume in our modeling, when we are going to model this behavior, we assume that the person chooses the site that provides the highest utility, the highest happiness. And then, of course, different people can have different preferences, okay? So there is also the option of just staying at home. And, you know, by observing different people choices in different occasions, then we can estimate a model that is going to capture this behavior. And that's how the model looks like. Is just wanted to show you an equation. So you see that there is a lot of math underneath this. And we have got the utility, which is a function of the cost, and the site characteristics, and an error term. And of course, we do not observe. This is a statistical model. So if you're familiar with regression, it's very similar to a simple linear regression, multiple regression. But obviously, we do not observe the utility, unfortunately. But we observe the choices. So this model can be estimated for the statistician among the audience, can be estimated as a conditional logic model, for example, is a discrete choice. So it's a discrete choice model. And based on these findings, we can, once we estimate these parameters, we can use them to simulate a variety of policy scenarios. And I'm going to do that for the island of Maui. And this is a picture from there. This is Molokini, a small volcanic crater next to the island, which is a huge recreational value. And on the background, you see the island of Maui itself. And what we did an online survey with the University of Hawaii and Kirsten Oleson. And we focused on recreational values from residents of the island. So each resident had, each of our respondents to our survey, we had about 360 respondents. Each of them had this Google Map API where they could indicate the recreational sites which they visited in the past 4 weeks. And of course, they had to indicate also where they lived and a lot of their socioeconomic characteristics and so forth. Based on this big wealth of data, we managed to estimate the model that I was telling you about. So this is just to show you some of the data. So these are the recreation origin in our sample. And you can see that that's basically where most people live in this area here, Kailua. And then there are in Kihei and on West Maui as well. But we managed to sample the entirety of the island. And then these are the destinations. And we can see that this is Molokini actually. And there, you know, we include in the survey not just coastal destination, but also all the other destinations like parks, trails, and these kind of things. And which can be codified as, in total, we have about 180 different recreation sites. And each day of the survey, so we have about 4 weeks, each day we know if the person decided to stay at home or to spend some money and time to go and visit a site. And we calculate the cost knowing Maui's road network. And this is the model. But really, it's the same model as we've seen before, and we have each day is a choice occasion, and we have the cost that characterize each recreation site and different site type and also site characteristics. Very quickly, just to show you the results, the fit of the model is very high. Pseudo square 0.65 is quite high. Cost is negative. What does it mean? That people don't like to spend money or time. That's okay. That's good. Is what we were expecting. Home is very high and positive. It means that most of the time, most of days, people are not going to be able to go outdoor. Even if they live in Maui, a good number of days they don't have time. Maybe they have to work and do other things. And then also we have high values for the most important sites of the islands, such as Haleakala and Molokini. But what really interests us for coastal management are the beach characteristics. And as we're expecting as well, lifeguard. So it's positive, which means that people are more likely to go to a beach where there is a lifeguard. Rock is negative, so people prefer sandy beaches than rocky beaches. But also this is what really, these last three parameters is what really interests us when we want to look at the impact of changes in ecosystem qualities, is the presence of coral and macroalgae and fish all have positive impacts on people's probability to visit a site, and therefore on their happiness, on their utility. Okay, more coral you have, more coral cover you have in a snorkeling site, more likely you're going to get there, and more fish is the same. So what does it mean really? Well, we can, now these are just numbers on a table, they're difficult to appreciate, but let's use this model to do some scenarios. So first, I'm gonna look at three scenarios. I'm gonna calculate the welfare loss, the loss in well-being generated by brown water event. And then I'm gonna talk about welfare gain from restoring Maui coral reef and welfare loss associated to coral bleaching events. So what are these brown water events? Where these are situations where we have storms hitting the island and sediments and maybe even pathogen and other nasty things get flushed into the coastal waters, which becomes this nice brown color, which means that then people cannot really go to the ocean and take part in recreation there. And this happens quite often, actually. And for some areas, some beaches of the island can be inaccessible for weeks in a row, for many weeks in a row. And this obviously is a problem for people. And so I'm going to use this model to simulate a very simple brown water event in which for 2 weeks, beaches on West Maui become unavailable to use. This is the welfare loss. Now, these white dots indicate the beaches that I made temporarily unavailable for 2 weeks. And this is the welfare loss quantified in dollar per person. What does it mean? It means if a person lives here, so I'm talking about residents. I remember you, this is only about residents, it's not about tourists. Tourists may have values that are as high as well. But what I meant to say is that if a person lives here, there is a big welfare loss. Why? What does it mean? Does it mean that this person is actually losing money? No, it's not losing money. We are talking about welfare, well-being. It means that this person is losing well-being, is losing happiness, and this happiness, however, can be quantified in monetary terms. What does it mean? And why? Where does this loss comes from? It comes from the opportunity to go to the beach. So if a person lives, for example, in this area, highly affected, they have or to stay at home, which is going to decrease their well-being, or they will have to travel to a beach far away here, for example, to go to the beach. And that is going to cost money and time. Okay. And it means that this person would be happy to pay, say, $20 in order to avoid such brown water event. That's the important part. This welfare loss is not a loss of money, but can be translated in a concept that is called willingness to pay. It means that this person is willing to pay $5, $10, $15 to avoid this brown water event. And of course, if the person lives farther and farther away from the beaches interested by the brown water event, then the willingness to pay decreases. If a person lives here, far away, then if we look only at the recreation, then they don't really care that much, okay? Because they wouldn't go there anyway. So their willingness to pay is very low, okay? It takes about 3 hours to travel here from here. So they wouldn't go to these beaches anyway. However, if they live in this area, then their willingness to pay is very high. So you can see these spatial aspects of this type of simulation is very important. And how we aggregate this is a total welfare loss of about $1 million if we aggregate these values to the whole island. And how can we use this information? Well, for example, this can be compared to the cost of doing measures to prevent these brown water events. For example, you can install buffer strips around roads or rivers in a way to contain the sediments. And you can compare the cost and the benefits and hopefully justify interventions that are going to stop this problem and make everyone happier, everyone better off. Okay. And this, of course, is just for the residents. And this was just a very common 2 weeks brown water event on a small part of the island. So if we calculate this for all the events that happen in 1 year, actually the values are much higher. Okay. And particularly if we consider climate change, which is going to exacerbate the problems if storms are going to become more frequent. So that's a type of scenarios you can do. Okay. Another type of scenario you can look at is a change in quality. So before we made some sites unavailable, and now we are going to change the quality of some other sites. Actually, I'm going to focus on one site only, which is Makena State Park. It's just I just choose that site for a simulation because it's already a state park, and this is how it looks like. And according to our study, it has, considering only residents, the park has about 200,000 visits per year. Considering that the population of Maui is about 100,000. Yes, 110,000. So that's Makena State Park, and I'm going to simulate what happens if we make it into a marine protected area. And here I'm making a very naive, very simple scenario, which also shows again why we need the input from scientists. Here I'm just assuming that the marine protected area increases fish biomass by 20% and coral cover by 20%. So it's just very simple, naive scenario. And let's see what happens. So these again are the welfare changes. And again, as you can see, the majority, I mean, the people who live close to the beach that has improved have much higher values than the people who live far away. Why? Because we are focusing again only on recreation, which is a specific ecosystem services. If we are looking at different ecosystem services, it can be different. Okay, here we are just focusing only on one of them. And also we can predict that there will be about the number of visits will about double, and that the total welfare gain will be about 2.5 million per year when we aggregate it to the entire island. Now, what if we introduce an entrance fee? However, we make it, we try to introduce an entrance fee which you can use to finance, for example, monitoring costs or other costs that are related to the creation of this marine protected area. Well, in this case, now you can see already from the map, the welfare gain becomes smaller, because now the people who want to enjoy that recreation there, they have to pay some money. So you can see how they become smaller, and the additional number of visits decreases. The welfare gain, as I mentioned, is smaller, but now we have revenues. Now we have about $1.4 million per year that we can use to finance this type of problem. So before the welfare gain, that were all well-being. So, but this is actual money. So this is actual money that our model predicts that we will collect by introducing this entrance fee. And still, people will be better off. I mean, people will still going to have a welfare gain, even though they will be paying this entrance fee. So, for example, we can use this type of models to summarize the scenarios. For example, this is the current situation, and then we've got an MPA, and we can see that the improvement of the increase in the number of visits and the increase in well-being. an MPA plus the fee. But then what we really should do is like a science MPA. So the change in the environmental qualities informed by scientists, not just my guess. And or we can, for example, see the impact of coral bleaching. So in this case, we have a reduction in coral cover. So we have a loss of, maybe we have less people will go there, likely, but also there will be a loss in well-being. And we can also combine the different scenarios, make them much more complex. And one really good aspect of this type of analysis is that they are really highly spatially explicit. So we can see where values changes. And if we change the qualities of sites in different areas, the value generated will be different. And they will be based on what's around the site and how many people live there, but it's a little bit more complex, but it's all spatially explicit. And obviously this is just one ecosystem services. Many others should be taken into account, but even just considering only recreation generates huge value. Here I just changed the quality of one beach, but if we change the quality of many beaches, if we do a larger marine protected area or a larger restoration project, then values will become really, really large. So what I hope I communicate with this illustration is that healthy ecosystems, even if some of these services do not have a market, they do have huge values. And we can be actually taking advantage of them to motivate MPA creation, to help with their targeting and their financing, really. Obviously, this cannot be done by economics alone. We do need the contribution of natural science, which has to guide and provide other information that will help targeting. Economics alone doesn't work. We need other aspects, natural science, but also social science and so forth. So I want to finish by saying a few things about what I would like to work, what I'm starting to work now related to these topics. So you may have guessed that this kind of research, this kind of modeling does require ad hoc surveys, like the one we did in Hawaii, and ad hoc expertise. And it takes some time and money, basically. And what I'm working towards is trying to answer this question: can some freely available big data be used to simulate to create similar models that can simulate similar policy scenarios? And ideally, if this data is available anywhere in the world, can we do that without any additional survey and without any additional data? In my opinion, there is a lot of potential from data from social media that some researchers, not me, so this is not from my research, is a picture from Spalnik et al., a recent paper. They used the data on social media to quantify the number of visits to different sites. Actually, they quantified the number of visits to all the coral reefs, all the different coral reefs in the world. So there is, in my opinion, great potential here. The issue with this type of analysis is that they just give you a picture of what's going on now, but they cannot be used to inform different scenarios like the one I showed you. However, I'm working towards developing some different modeling approaches that are inspired by the travel cost, but they only require visitation data. So they do not require knowing where people live. And therefore, you can use these models if you have this big data available. You can use this model potentially anywhere in the world, and anyone could, if these models become available, they could be able to do this sort of scenarios like the one I presented you for Maui, for potentially anywhere in the world in a freely available software. So that's my aspiration in the next years of research, obviously, subject to funding, which is a problem that researchers always have. So as a conclusion, hopefully I didn't take too much extra time. As a conclusion, just to talk more in general about environmental economics, we are not trying to put a price on nature. we are trying to highlight some of the values that nature have in order to put them in the spotlight so they are not ignored by markets and also by some policymakers, I guess. And obviously, I don't believe that policy decisions should be based only on economics. It's just a small piece of the puzzle, but hopefully is a useful one alongside natural and other social sciences, of course. So hopefully I persuaded you that now we can become best friends in research or in conservation. And if I manage, you can of course contact me always here and my email. I'll be happy to hear from you. And thank you, Malik. I think I'm finished with the talk.
Thank you very much, Carlo Fezzi, for your excellent presentation. Very interesting aspects you have pointed out. You were right on time. Thank you for that. We already have a few questions, so I believe that we can jump directly to the questions and make the best of our time. So the first question received from a YouTube viewer is, how can we calculate the value of an ecosystem if it is not a recreation area?
Okay, so that's a great question. It depends which value. So as I mentioned before, an ecosystem are going to have a plurality of values. They're going to have many values. In this exercise, I've focused on recreation because there is a lot of science on that specific aspect of on that specific values, and we have I mean 20-30 years of models, of thoughts, of scientific improvements, and so we are able to do that with a certain with a certain degree of I want to say the word precision, because there are always huge uncertainties when we do this kind of stuff, but with a strong theoretical foundation. Other type of values can be captured in other ways. For example, you could, if you think about carbon capturing values, so a well-functioning ecosystem probably can have higher value from this point of view as well. There can be also other values such as existential values. So people can feel a higher degree of happiness by knowing that a nice ecosystem exists, even though they are never going to visit that ecosystem. For example, I like the ocean. I'm very happy that whales are in the ocean, even though maybe I'm never going to meet a whale. I can still be happy because I know that they are there, and maybe I can see movies or documentaries and that sort of things. And we can also do methods to quantify such values. For example, there are things called, so what I used is a revealed preference approach. You can use stated preferences approach, where you ask people to make choice, and so there are different aspects different techniques that you can use to try to value different aspects of the ecosystems that maybe are not recreational, do not have any recreational use. Each technique comes with drawbacks, so you need to be aware of the drawbacks of each of them. The microphone.
Thank you very much for that answer, Carlo. We have a few more questions coming in. Around 10. Let's try to manage the time the best we can. The next question, Carlo, is within the context of the pandemics, if tourism collapses, how does it mean that the value of ecosystem collapses?
That's a thorny question. So, okay, first of all, my analysis has nothing to do with tourism. So I only talk about residents, okay? Residents, so the values for residents. If tourism collapses, so in economics, at least in economic decision making, normally you don't make, obviously I'm not saying that we should make decisions based only on economics, but if we take the economist value, we also know that we do not base decision on what happens on one specific year. We want to plan many years in the future. That's what those are the arguments about you know, cutting emissions now for climate change, for example, to prevent problems in the future. So really, maybe tourism may collapse, or may certainly collapse this year. We observe much lower tourism fluxes, but in the future, hopefully, when the pandemic stops, everything is going to start back again. So yes, maybe for 1 year, if you use only these techniques, you will have a decreasing value if you want to estimate the value of tourism, which I haven't done, but you could use these techniques to estimate some values for tourism. But then in the following years, we can expect the values to go back again. So you can still, yeah, you can still be a little bit positive for the future. Let's say.
Thank you, Carlo. Next question. This is some questions that were placed for more of a discussion, but I will try to read some of them out for you. Anthropocentric view does not take into account the huge part of stakeholders that in reality are all the non-human living being. Ethic problem. Carbon credits have been a way to give values to non-marketed goods in the frame of climate change. Could we envision to have a stock market for a natural capital?
Okay. So
clear for you, Carlo?
Sorry?
Was that clear for you?
Yeah. So the first question is about the anthropocentric point of view. Yes, I mean, obviously, it's an ethical problem, like you're saying. At the end, who makes the decisions are at the end of the day are humans. So that's why taking that stance allows humans to make decisions and informs. The idea is to make decisions where humans are going to be happier. Humans are going to be better off. If you start including in your decision process also the point of view of whales or parrotfish or eagles, then it's impossible, obviously. I mean, even thinking, it's impossible to come to an optimal, even in theory, because obviously the rabbit will want all the eagles to be extinct, and the eagles, vice versa, will want to predate on all the rabbits, for example, and just putting two animals against each other right now. So by taking an anthropocentric point of view, we can at least, obviously with all the problems that these kind of techniques have, we can at least in theory reach a comparison between cost and benefits that are gonna support some of the decisions, some of the policy choices.
Sure, Carlo. And also a second question from Alicia. Could we envision to create a system where not just extractive activities like fishery will receive subsidies, but also the natural capital through integral protection of certain areas?
Yes. Yes, I think, yeah, I mean, that's ideally, right? So you're talking about things like payment for ecosystem services. There are these sort of things that happen for land use. And for example, well, I worked in the past a lot on land use, so I'm a bit more informed on that, even though my hope for the future is to work on coastal issues and maritime issues. But for example, in the European Union, a large amount of the CAP, so the Common Agricultural Policy, is dedicated to paying farmers to have good farming practices, which are not harmful towards the environment and provide ecosystem services. So it's very similar mentality, very similar approach can be taken also for coastal areas, for fishing, or these sort of things. So yeah, it should be done.
Thank you, Carlo. We also have a viewer that has question about the science of marine protected areas on Maui. If you could quantify the details.
Yeah, I mean, which details? Sorry.
For the person is asking, why is the science of marine protected areas on Maui more? Maybe the stats that you.
Oh, in the presentation, no. Okay, no. I haven't done any. No, that was just some numbers I put. I mean, unfortunately, my simulation was just wishful thinking. I just decided that a marine protected area was making 20% more coral and 20% more fish, just for simplicity. My point was that actually these sort of scenarios should be informed by scientists, by natural scientists, ecologists, marine biologists, who are going to tell us what's going to be the actual impact of the marine protected area. And of course, we can simulate a wide range of different impacts to take into account uncertainties, and we can do all these sorts of things. But yes, did I answer? I hope. Yeah.
Yeah, sure. So it was a simulation, like for a scenario that you created.
Yeah, just a scenarios. I mean, I wish I had some scientists that are going to tell me, no, these are the numbers you should use, and yeah.
Okay, another question, this time from Angola. How can we quantify the value of African coasts if we do not have a clear picture of the value of the costs of recreation?
So how we can quantify the value of African coasts?
Namely Angola. In this case, Angola, for example, the viewer asks, if we do not have a clear picture of the value of the costs of the recreation. So is it, how important it is to have the value of the cost of recreation in order to
the cause, like the reason why people go recreating in a certain place. That's what you mean, right?
In order to value the African coasts.
Yeah. I mean, in this model, I did not have the reason why people go to a certain place, but you could include it, but really it's just different ways to specify this model. But really, you can include it, you can also not include it. You don't really care why the person goes there, but you care about the characteristics of that place. So if a beach, for example, in that example, the beach has a nice coral and a lot of fish, maybe some people go there for swimming, some people go there for snorkeling, some people diving, some people just stay at the beach. It doesn't really matter as long as they go there, and we observe that actually beaches which has higher ecological status, which have nicer ecology, people go there more often. They're willing to spend more money and effort to get there. It means that ecological characteristics have a value for people, and then we quantify that based on this model. So I think it's the same will work in Angola as well. So it's just you could have a model. You could have a model that distinguishes between the different uses of the recreation sites, but it's not necessary.
Thank you, Carlo. Next question for you from Christian Diaz. Carlo, how can the U.S. financial and environmental normatives related to conservation help advance in your research?
Sorry, I'm confused.
Read it again. How can the U.S. financial and environmental normatives related to conservation help advance in your research?
So I'm not familiar that much with the present normatives in the US. So what I can say is that I'm hoping that this kind of approaches, this kind of research can show the values of, for example, doing conservation practices in specific areas, and can be used to spatially plan and compare the values that different areas generate, and therefore it can be used to identify, alongside, of course, natural science and other considerations, social science, the best areas for conservation and the values that they will give to people. and also ways to finance them. For example, I did this simple simulation with this access fee, for example. That's a simple way. In the case of the brown water event, we could think about, for example, a water tax, or just a higher water bill, for example. Even a few dollars per month would be enough to finance this kind of programs.
Sure. Another question from Louisa Carl. Do you think that teaming up with the restoration programs could help back up data for your surveys concerning repopulation of fish and coral?
Mm-hmm. Yeah, I mean, that would be great. Yeah, of course, this kind of interdisciplinary work, it requires, it requires this type of information for sure.
Definitely, yeah, sure. Carl, which parameters did you use to calculate ecosystem? This is a question from Zachary from Benin.
Which parameter did I use to calculate an ecosystem? Oh, so I did not really calculate an ecosystem. I just calculate. I just find where are the different recreation sites. So the unit here is recreation site, and then the characteristics of the recreation sites. We use different GIS layers. These different GIS data that told us how much corals you have in this area, how much, which is the fish biomass, and other ecosystem characteristics. But I didn't define an ecosystem itself. I just define a recreation site, and then I try to find what's in that area, what's going on in that area from an ecological point of view, but also not. For example, lifeguard, yes, no. If there are waves or rocks versus sandy beach. So all the different things that characterize the recreation site.
Sure. I'm going to pass the word now to Mr. Frank Mueller, who has a question, and then we can continue with the other written questions, okay? Mm-hmm. Please.
Oh, we cannot hear.
We can't hear you. Not yet.
Okay. He's going to type. Okay.
So he would like to ask the question at the end? Okay, sure. So let's go on. Next question, Carl. How do you think your work could contribute to the Global Ocean Account initiative? And which are the similarities and the differences with your work?
So this is another difficult question. So on one hand, accounting, as far as I understand, has a higher focus on markets. So while economics wants to focus more on values, so markets and prices and values. So that's one difference. However, there are also a lot of valuation techniques that I haven't talked about today that can be used to improve accountancy methods. So that can be definitely a similarity. So maybe for recreation, usually in accountancy, there is more focus on tourism or on the part of recreation that creates revenues itself. And that can be actually done. It's a slightly different approach, but can be done. But also there are other ecosystem services such as carbon, for example, which can be taken into account. So the valuation methods are slightly different, I would say, but it depends, because also accounting there can be different point of view. So it depends which one they are going to follow in the ocean accounting project. But there are definitely many similarities, but I think it's we will have to talk about this more in detail to be able to see, but definitely there is a lot of overlap and connections. Yeah.
Okay. Just working that. So Carlo, we still have two questions, three. How do you cope with conflicting views on how to evaluate the environment? There's an example, mangroves may be considered of no value for real estate developers unless they build something. On the other hand, fishermen sometimes do not know the importance of mangroves in coastal biodiversity, which will impact their catch. Others may see mangroves as a source of fuel or building materials. If these uses have different evaluations, how can you combine all that conflicting views and provide a single value?
That's a fantastic question, I have to say. And I'm not sure you should provide a single value. I think you should probably, first of all, it sounds like that there is an information problem if fishers are not aware of the importance of mangrove. So that's usually, those are issues that should be tried to be resolved. So the fisher should be made aware of this importance. You can do it via participatory methods, for example. And I don't think you should provide one single value, because one thing that can be hidden by this kind of choice would be if there are losers or gainers from a project. So if you provide a single value, you will hide that. But that's important. It's important to know what the different stakeholder groups hold as values. So I think you should probably try to present a picture that is more disaggregated as possible, that highlights the need of certain people versus the need of other people, and then it's not the role of the economists to decide what to do, unfortunately, or fortunately, because these issues are quite difficult. So I guess you try to highlight all the different values, and then it's the policymaker, which is going to be supported by stakeholders, that they will have to make the decision. But I don't think you should produce one value, but it's a great question. Yeah.
It's great. We still have two more questions, one from Omnia Ibrahim and one also from Frank. So we will be able, due to the time setting, we will be able to complete all of them and answer all of them. Carl, so I will ask you, this is a question from Omnia Ibrahim. Some of the environmental projects, services or products may have a value or a competitive value that may make it successful in the market through the marketing plan and through the marketing strategy and the marketing process that will be established, like that of the aquaculture, and make it successful project by making an innovative marketing plans, by making the pollutants and the creation of the project, and the marketing process by making a marketing strategy is resilience. Let's try to understand this question. It's a bit confusing, but let me see if I can figure it out for you, Carl. Did you get the idea?
Well, I got the idea that that some ecosystem service will have a market behind them, which is, yeah,
exactly.
Which is something
some kind of a question on the link of marketing plans in the pollutants, in the creation of projects, in the strategy, in the resilience. This question is not clear. I will ask Omnia to redo the question, please, and while we jump to Frank's question. As you see, Carlo, the webinar was sponsored by several large groups. We are all interested in a significant contribution to the UN Decade of Ocean Science for Sustainable Development. How can we best partner between science and economists to do something at the scale of the Atlantic Basin or larger?
Okay, that's a very large scale. I think I'm a very strong supporter of interdisciplinary, multidisciplinary research. So I think probably having more economists coming to events organized by natural scientists and vice versa is a good starting point. Try to work with people who want to do this type of work, who want to do interdisciplinary research or projects in general related to policy or so on, is probably the best idea. We have obviously we have our meetings between environmental economists, and you know, I think the organizers of such meeting will be very happy to have contributions from oceanographers, ocean scientists, marine scientists, and so forth related to this. So really, it's a matter, I guess, of just finding the right people to dialogate, and then I think we need to do it. Yeah. I think it's just a matter of, you know, connecting people and just trying to do some work together.
Thank you again very much, Carlo Fezzi, for your wonderful presentation. A very interesting insight on economic valuation for spatial targeting of coastal ecosystems. Many interesting questions were placed here today. I would like to highlight that this session was co-organized by several collaborations, the Marine Biodiversity Observer Network, the Ocean Biodiversity Information System, the Ocean Best Practices System, the Global Ocean Observer Network, and also the Ocean OBS Research Coordination Network. And also, finally, least but not the last, the Air Center. Thank you very much for this opportunity, for Carlo Fezzi, for this wonderful presentation. I suggest who got the contact of Carlo to keep in touch. He has shown availability for further contact from Cabo Verde side. We will surely get in contact with him. Thank you very much again, everyone, the viewers, and Carlo for this presentation. Have a nice day.
Thank you. Thank you. Feel free to get in touch, definitely, if there is anything you want to discuss. Yeah.
Thank you, Carlo. See you next time. Bye, everyone.